All right, so again, lesson 7 is on the addition and subtraction of rational numbers, and we really want to get into the real world problems, how you can set up equations and use the number line to help you visualize your solutions. But one more time, let's do one more example here. Find the following difference and represent it on a number line. I want to change it to addition. So I'm going to say keep the negative 5.5. And a lot of times we want to change that first number, especially if it's negative. No. I want to change the minus to a plus, and I want to change negative 8 to its opposite, which is a positive 8. All right, so this is negative 5.5 plus 8. So representing on the number line, remember, we want to go with our first number here, negative 5.5. And so negative 5.5, remember we're starting here instead of 0, comes halfway between the 5, negative 5, and negative 6. Now I am going to go to the right, because it's positive, 8 units, because the absolute value of 8 is 8. So to help me out, I am just going to kind of put halfway markers in here. That should be good enough. So when I count 1, 2, 3, 4, 5, 6, 7, 8, I want to make sure I'm going one full unit. So if I'm going from negative 5.5 to negative 4.5 to negative 3.5. So that right there looks like it puts us at, oh, bad. But anyway, make that really thick so it looks right. That puts us at a positive 2.5. Okay. There we go, positive 2.5. So we know that negative 5.5 plus 8 equals a positive 2.5. All right, so let's get into some problems that are going to look a lot like your homework, so make sure you pay really close attention to this. It says create an equation and a number line diagram. You need to do both. So Samantha owes her father $7. Now, if she owes him $7, the integer that would represent that for me is a negative 7. And then she got paid $5.50. So that's a positive. So she owes her dad 7. She gets paid $5.50. And that equals the amount of money she has left after she pays dad back. There's my x. There's my equal sign. This is the equation I'm looking for. So just sketch. I know I have this ability to just draw a line like this, but you guys have the ability to draw a straight line, which I can't even do with a tool. And then let's think about what's happening here. We're going to start at the negative 7, and then we're going to take the absolute value of $5.50, positive, going to the right 5.5. So if I'm starting at negative 7 and I'm going to the right, I'm going to start, oops, and I'm going to make sure I change off my drawing here. I'm going to start at negative 7, and then I'm going to go to negative 6, negative 5, just sketch it, negative 4, negative 3, negative 2, negative 1, 0. I don't know how far we need to go, but this looks like it should be good, right? Why not? All right, so remember, we put the tail at negative 7, and I'm going to go to the right 5.5. So from 7 to 6 is 1, so it's 1, 2, 3, 4, 5, and then I want to go halfway. I'm going to draw my vector over it. And it looks, sorry guys, ugh. It looks like this is going to be halfway between the negative 1 and the negative 2. So I believe that x is going to be equal to negative 1.5. But remember, what questions are they asking? If she gives that money to her dad, how much do we still owe him? She doesn't owe him a negative 1.5. She owes her dad $1.50. All right, so you just want to make sure that your answer makes sense to the question. Okay, so she owes her dad still $1.50. All right, so let's look at another example. Again, equation and number line. At the start of a trip, a car's gas tank contains 12 gallons. Seems positive to me, but it consumes 10.5, so I think that's going to be negative. How much gasoline is left in the tank? So I'm going to take 12 and I'm going to add it to a negative 10.5. You could also you could have, maybe instead of thinking this as a negative 10.5, you could have said, if I erase here, 12 minus 10.5, which equals x, the gas to the left. But remember, the other thing you could have done is keep the 12, change a minus to a plus, change 10.5 to a negative 10.5. Still equal to x though. All right, so before I kind of put my number line together, I'm going to focus on the addition one right here. And I'm going to start at 12, and then I'm going to go to the left 10.5 units. So if I'm starting and going left, I'm going to put my 12 down here, and then I'm going to say, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. I think that should be enough. Okay, so put the tail on the 12, and then I'm going to the left 10.5. So I'm going to go to the left 1 unit, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then I want to go another half. So when I draw my vector, I can see that it's going to be halfway between the 1 and the 2 right here. So my x is going to be equal to 1.5. Notice how I wrote this one as a fraction, but this one as a decimal. This one, they were talking about money, that's a decimal. This one, they gave us 10.5 as a fraction, so I want to make sure my answer is 10.5 or my answer has a fraction, not a decimal. So how much gasoline is left? 1.5 gallons. Okay. Really, nothing's really changing here except we don't have to go from 0 anymore, and we might have to deal with some fractions. One more. Okay. A fish was swimming 3.5 feet below the water surface. So that's negative 3.5 to me. 4 hours later, the fish was at a depth that is 5 1/4 feet below where it was. So again, we want to think of this either one of two ways. Negative 3.5 minus 5 1/4. Or if you think of this as a negative 5 1/4, you could think of this as negative 3.5 plus a negative 5 1/4. But either way, set it equal to your unknown, your variable, your x. Okay, well, rational number, fraction, decimal, integer, whatever, this case can be fraction, represents the position of the fish with respect to the water surface. So I'm going to use a vertical number line for this and kind of squeeze it in here. I know I'm going to start at negative 3.5, and then I'm going to go down, left or down, 5 1/4 units. So just to make things nice, I'm going to put 0, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, keep going, negative 7, negative 8, negative 9, negative 10. I think that should be good. I have room for one more, negative 11. Okay, so we put the tail at negative 3.5. So here's negative 3, here's negative 4. Negative 3.5 is going to be halfway between. Now I'm going to go down the absolute value of this, which is 5 1/4. So let's start by going down 5. And again, I'm dealing with this half. So I want to put my little half marks in there so I can make sure it go down 1 unit each time. So that's 1, 2, 3, 4, 5. But I got to go down a fourth. Now, a fourth is half of a half. Does that make sense? So when I go down a fourth, if I went all the way to 9, that would be a half. But I got to go half of that distance. And so I'm going to go half right here. And I'm going to draw my vector. And we're going to see that we actually end up at negative 8, negative half, negative 3/4. You can break that up into fourths because it's not quite to the 9 yet. So x equals a negative 8 3/4. So what does that mean? Well, it means 8 3/4 feet really wish I need to find an undo button on here. 8 3/4 feet below sea level is where the fish ends up. All right, ladies and gentlemen, big takeaways. When we do the number line, we don't have to start zero anymore. I know some of you will like that. But we also just want to be careful when we're dealing with rational numbers, including our fractions and decimals. But the process still stays the same.